Okay. All right. Let's go ahead and get this started here. My audio is okay here. So, welcome back, everybody. We are talking about the Graph Toolkit that was just introduced in Unity 2.6 here in the last month or so. And this is a framework for creating editor tools in a graph format. So this is similar to like the VFX graph and the particle system graphs. They are building the new animation system on top of this graph toolkit as well. It's also similar to the visual scripting tool that is currently out there. I believe it's still getting updated. And yeah, so this is kind of replacing the called graph framework that's been around for a couple of years. And this is going to be kind of the new standard going forward here. And we're just going to take a look real quick about the what the toolkit is, what it can do, what it cannot do, that kind of thing, and a couple of the samples that they have. They have a little sample here about creating a texture, and there's one that is creating a dialogue tree system. So first, we'll just go through real quick how to install and what versions we're on and everything. So this is using Graph Toolkit 0.3.0 experimental one. And this is kind of hot off the presses. 0.3 just came out yesterday. So hopefully this didn't break everything. And to install it, you just, in your package manager, you'll install it as com.unity.graphtoolkit. And this is a experimental package right now, so things are changing. Just recently with this 0.3, it changed the way you create some of the node options, which we'll go in a second here. So at its core, this is an editor tool system. So we can see what here it kind of looks like. You have your nodes, you have a blackboard here for your variables, you have the graph inspector, and then you have your various nodes. There's placemats that you can group nodes together. You can make sticky notes. There's a neat little mini map here in the corner. And you can also make subgraphs, so you can have nested graphs within graphs. I guess somewhat controversial is that it is not using the actual Unity inspector. It has its own graph inspector that eventually, not at the moment, that you'll be able to create your custom drawers and whatnot for different components and variables for your graph. Some people really wanted it to be more integrated into the main editor, but I think they have opted to give a bit more flexibility to the tool makers here. And like I said, this is a editor tool, so there is no runtime support built in. So you won't be able to, say, see your graphs in game. So they are purely for creating editor stuff. Now, we'll see with a couple of these samples, you can convert your graph into a runtime format, which basically just involves creating a scriptable object of all of your graph nodes, and then reading that scriptable object at runtime. So yeah, we'll just see here just what it provides, the graph creation manipulation, the UI, and whatnot. Does not provide runtime graph execution backend. So basically, your nodes are purely visual. There's no runtime editing, rendering of the UI graph, so you won't see this in game. And application specific node implementation. So we'll get into that in just a second here. I'm not going to go over every feature here because a lot of these aren't very well fleshed out just yet, but we will go over what our nodes are and how we can create them. So basically what your node is a name, a title. You can have node options, which are basically variables that exist purely within the node. And then you have your inputs and your outputs. And your inputs can be variables, so you can have variables that feed into these inputs, or they can be in line here and just kind of be constants in your node. And nodes support all of the basic Unity types, and also you can create your own component types for this as well. Our node ports, implement code. We'll go over the code in just a second, but basically it is a node abstract class that you can implement in order to define your different ports for inputs and outputs. Same for our options here. And you have your basic node, which kind of looks like this. And you also have a context node. And the context node basically has sub blocks that you can add to your node or other options. So you can create blocks that can go into a context, and the blocks can be defined for specific contexts, or you can have like a universal blocks that will go in multiple contexts. Here in this screen, there's some examples of what context nodes can look like. So here, this would be something for post-processing, like for your camera settings for Cinema Machine or whatever. So you could have different context blocks for your different visual effects. So like your bloom, vignette, or whatever. Instead of having to do this within Cinema Machine or in code, you can have your designers come in and rig up one of these blocks in order to set up Cinema Machine or whatever your post-processing stack is. And this one is for a quest system. So this would be setting up different quests with a name, description, a type. You can have objective blocks or reward blocks. You can have multiple objectives or multiple rewards. And this is something that your quest designers can go in and design quests and quest chains if they want, without having to bug your programmers to create different things of like rewards and objectives and whatnot. We can look at portals and sticky notes and placemats here in the editor. One of the interesting features here is missing items. So if anything in your code gets deleted or renamed or something, it's not going to destroy your graph. You'll just have nodes that have missing text in them. So instead of having the name as message. So instead of having like cinematic look, if this got changed to something else, then this would say like missing node, and all of the connections and variables and stuff would remain, but you would have to re-implement the new node here. And we'll look at graph processing here in a second. All right, let's hop over into the actual editor. So these are a couple of the samples that come with the toolkit here. We have the visual novel graph, which we'll go over in a second here. This is, so what we can do here, this in. So when you want to create a new graph, first I'll show how to actually do it, and then we'll look at how it actually gets coded. So here under create, we have Graph Toolkit samples, and then we have a texture maker and our visual novel director graph. I also created a tutorial graph as well. So this is going to be a texture, I believe. So we're going to just call this whatever. Okay. So here is our graph window. We've created a new graph. It is completely empty, and we have a error message here immediately that says to create a create texture node in your texture graph. And the reason we got that is because the importer is trying to create a texture from this graph. And we can look at that real quick here. Here is our texture maker graph. So we have an attribute here at the very top that is the graph and the asset extension. When you create a graph, you just extend the graph class here. And here in our class, we make an asset extension string. You want to make it a constant, and this is going to be the file name or editor extension or asset extension name for our graph. So when we created this texture maker graph, it is texture maker graph dot texmkr. This is what the importer will look at when it tries to import this asset. So we have a menu here for creating our asset. And this is similar to how you would create a scriptable object. But this has a create asset file, and this will create the actual graph asset for us. There is some other functions here for checking the validity of the graph to make sure that it has everything you need. So in an empty graph for us, for this texture, it needs a create texture node in order to create our texture. So this is why we got the error message on creation here. Here we have a callback, which is from the graph class. So whenever the graph changes, we roll through this check graphs for errors. And down here, this is just a how we look at the different values of the different nodes. So how the texture graph works is it goes from the create texture node and worked its way backwards through the graph in order to create the texture that is going to be ultimately created. We'll look at the importer here, just show exactly how it works. But first, we'll want to look at what the actual create texture node. So for the nodes, we want it to be serializable, and basically we're just giving it a name and the width and height of our texture. And then we just have a single input port in this onDefined ports override. This is where we actually create our inputs for the nodes. And then this create texture node only has a single input. That's going to be a texture 2D with this name. So strings are used liberally throughout this, and it's often a good idea to use constants, strings up in your variables instead of having just strings littered all over the place. This just prevents typos from when you're copying and pasting strings everywhere. So back in our graph here, we just want to right click and go ahead and create node, and we are going to create a texture node. So this is our texture node. We can click here and drag out, and can let go to create a node here, or variable, or whatever you want to feed into this. We could make it a constant here. This is our color, and we can color whatever. We can also create a new variable here. It's whatever. You could rename it. And you can drag your variable from the blackboard into your graph here. And then you'll see in the blackboard, you have your variables here that you can change. You can change the type, so wanted. So the variables that show up here are the variables that are in your nodes. So if you wanted to create a, let's say, form node, this is where our color variable can come in here. And this node here will output a texture based on whatever color we have put in here. And then we can connect our nodes to output to our input. As long as they're the same type, they will connect. So this will create a texture for us of this color, of the height and width that was in the create texture node here. So here we save, and then back in our graph where we created it, it's our texture. If we change the color here, we change our texture color after we save. So for all intents and purposes in the editor, this new texture is just a texture. But if you double click on it, it will open up this graph that we can use to modify this texture. So if we used another node, a bean color node, here we can actually delete this here. Then we might want, sure, delete that. Just make a texture here, and then we can actually add texture to this arrow. So now when we save, oh, it didn't like that. This might be because the texture is the wrong size. Oh, it's just not readable. That's fine. Let's make it another. And this can be, okay. And then once we save, we get yellow-ish. Okay. So for the create texture node, which we have. What this is doing is this is looking up here. I guess we can look at the actual import. Okay, so our importer here is actually where most of the magic happens. So whenever you import this asset, which is from our texture maker graph asset extension, this is why you made it a constant. Whenever this gets imported, this import script will run. So here we have our actual 2D output texture. This is going to run whenever we import our asset. So what we do is we grab the graph from the graph database, which is just going to be the asset that's in our project folder there. And then it's going to call compile graph. And all compile graph is going to do is it's going to grab the first node. In this, there's only going to be one create texture node. So you just grab the first or default there. And then it's going to basically work backwards. So it's going to grab that texture node, and then it is going to get the import, and then it's going to resolve that port. So in our graph here, it's going to get the mean color node and nodes. So our mean color node is going to have the node abstract class, and also we have this texture evaluator node interface. So all of our texture nodes are going to have this, and the evaluate texture port is going to resolve itself and also resolve the input ports that it is given. And basically it's going to take an average of each pixel. This is where that happens here, and then spit that out. So here what this is going to do is take the uniform node and then average them out. The uniform node is just going to take its color and then apply that to its output here. So we have the create texture node width and height. So it's just going to create a texture of that width and height of that color. And yeah, that is basically super simple how this graph node actually will work. Now we can take a look at our visual novel sample here. This one is slightly more complex. In this graph here, we have different node types. So we have our background node, we have our set dialog node, and there's all the different types of nodes. This one. We have a start node, and then we have the background node, and there's a wait for input, which I believe that gets added by the importer here. And this is not like, super complex at all. It is straight linear. So it will go through these nodes one after the other, and then it will execute on what these nodes are set to do, which we can look at editor-wise. So our start node is basically going to be an empty node here. Okay. So the start node, the base visual novel node here. So this is going to be a node that all of the visual novel nodes inherit from. And there's just going to be a single input output node that is going to be basically directing the flow of this dialogue sequence. And since they all have the same name, we are just going to have this function here that's going to add the execution port to all of our nodes. So it's just going to be our input node with its name. We have a display name, which is not technically needed. We have a port arrow, which I don't think is needed either because it's the default. And then once you build a port, you just have to call .build on it. Options are a little bit different. They don't have the .build options. So we have our set background node, which all this is going to have. This will be the background for the visual novel. And so it's just going to set a background sprite here. So all it's going to have is an input port of type sprite. So for example, in our set background node here, the initial one is going to be this office sprite. Here in our dialogue node, we'll have an actor's name, a actor sprite, a actor location. So this is going to be either left or right, and their line of dialogue. So in this visual novel, it's just going to be the player, Wyrick, and Notice. And so for each of our dialogue nodes, it's going to be either a different player or a different actor in it, whatever. So players is going to be on the left with no sprite, and the NPCs will be, it depends on just who's talking, either left or right. And we can look in the importer, since this is actually going to be running at runtime. Here at import time, what this is going to be doing is saving all of these as a scriptable object, as you can see. And then we have our different nodes. So the first node is going to be the background node and the sprite. Second one is going to be our dialogue node, which has our player, actor sprite, index, and our dialogue. Here in the importer, we are just going to be loading the graph asset like we did before. Here we have a start node, which is not actually going to be doing anything. It is just where we decide to start our getting the next node. So here, since we are converting these into runtime assets, this is going to just be creating a scriptable object, which is a visual novel runtime graph. For this, it is just going to be a list of visual novel runtime nodes, which is in the abstract class here. Here we have in our runtime, we have the runtime nodes here. So at runtime, we'll have the actual node itself, which is just going to be a class that has the sprite in it. And there is also a executor. So this will be run by, call it the visual novel director. And then this will be running to actually affect actual gameplay. So this will just be a task that gets queued up, and it will set the background image to the sprite that is in this node. Let's go back to the importer. So basically what next node here is going to do is it is going to take the current node and it'll look for the execution port node, which we saw that every node has an input and output of this execution port. So there's only going to be one for each node. So we just look at the output node of the current node here, and then we basically return that node. That we have an first connected port, which is part of all ports, and then we just return it. So we don't have branching nodes or anything like that. You can have multiple ports. So if you wanted to do branching dialogue with choices and whatnot, we could have a choice dialogue node that can branch off depending on what we actually choose. So here, what this while loop here is, this is going to loop through the rest of the graph, and it will add the runtime node to our node list. So here it's just going to keep going until we hit the last node, and at the very end, actually, you can't actually click in the minimap. I think they're going to add that. So here at the end, there is no connection port, so it's going to be null, and that's where the import is going to stop. Once you've gotten everything in your list here, then we will add the object to this asset. So we are saving the runtime asset into this one, then setting it as the main object. So once we do that, then our visual novel graph kind of stops looking like a graph, and in the inspector, it is just the scriptable object. And then at runtime, we will take this scriptable object and we can use it just like any other asset. So here in the visual novel director, here we have our runtime graph, which is going to be that list of nodes. And then we have all of our canvas stuff for displaying the background image, the actor's name, the actor's left and right image, and we'll look at the director. And at this point, it is not really graph related anymore. This is all runtime stuff. So all we do here is basically on start, we start running through our node list, and from top to bottom, we execute each one in sequence. You can see. So here in the translate node to runtime node, this is where we are grabbing the graph nodes and then assigning it to runtime nodes, depending on which type it is. So we're switching on the node type, and whether it's a background node, a dialogue node, or a wait node. We're going to add that specific runtime node to our runtime list. And so here, we're going to add a dialogue node runtime, and then we just automatically will add a wait for input runtime. So we don't have to add one of these into our editor graph after every one if we want to wait for the user input. So there's one here for the dialogue. The set background does not have a wait, so it will immediately go to the next node. So if you have nodes for like background music or whatever, it will load them all at the same time before stopping for input. And we can take a look and see how this actually works. So this is the input provider. This is just basically listening for a click event, I think. I think it's any set to space or left click. So when we hit play, it's going to start. It'll start in the office and continue on. So yeah, and it will on. I think never actually looked at how the text is getting. That's all part of the dialogue runtime. Yeah, okay. That's this kind of typewriter and task here. Control you have over that. And there we go. And then at the end, else. It's the end of the graph. All right. Let's see. Before we wrap up, I want to talk about the context graphs and the quest system that I think got broken. Dang. Okay. So I made an attempt of making a little quest system here, but my importer got broken. And I don't know why. All right. But we can at least go over it. Okay. So in a context, you can have node options and also node blocks. So that's still busted. Here, this will work, I think, still. Okay. So I have a prerequisite block here, which in theory will check if the player meets these prerequisites before it will grant access to this quest or this quest chain. So technically I could have this prerequisite block here, and then the player would have to be level 10 in order to start this quest chain. Or we could have it where it needs to have other quests completed first before starting it. I guess you could have whatever prerequisites you want. Like, you want to have class quests or quests where you have to have a certain item in order to unlock this quest or quest chain. You could do that as well. You can have multiple ones here. So you can hit Control D to duplicate. So you could have multiple prerequisites for whatever reason. Here in the objective block, I have a option for the type of objective. So there's like kill, collect, fetch, escort. And according to whatever option I set here, the parameters here will change. So for kill, there is an enemy to kill and an amount to kill. For collect, there will be an item to collect and an amount. For a fetch, it'll be an item to collect and a person to give it to, which may or may not be the same as the quest giver. So my idea here was there will be different types of quests. So there'll be a story quest, an event, or a side quest. I don't know what the actual difference between story and side quest would actually be, but for events, what I wanted to do was have like a world event that would spawn for this quest. So it might not just be part of the different objectives. So here you could actually have multiple objectives. So you might have multiple things that you have to kill in order to complete this quest. This is also where I kind of wanted to do branching quests. I haven't thought out completely on how that would work. You could have quests that roll into dialogue, and then you would have dialogue nodes that could lead into choices that could go into different branches of said quest. Haven't quite filled this part out yet. In order to make a subtree, you can basically, if you right click on a node or a group of nodes, you can make them into a subgraph section, or subgraph of this selection. There are some bugs here, and that is basically, I'm not sure if this has to do with this error message or what, but can't see the different nodes, only the dialogue node for some reason. I don't quite know why. But if the node is already in here, I think it's in the order I created them. But I can still duplicate them and move them around. Also, if you were to take this, you could duplicate it or move this around. So how these would get processed, you could change that. So my idea here with the dialogue node was these would be scenes with each person and line of dialogue here, like kind of talking back and forth or in order. There could be multiple people here, and you could switch the order of the dialogue if you wanted. But if you duplicate this, it kind of breaks everything. I can still add a node, and I think if I save, that brings it back. I can't because everything's listed. Yeah. So if I wanted to make a subgraph here, I could select these two. Create a subgraph. Nope, because that's broken. But you can move them. You can just look at that at all. You can create a placemat here. Click the both here. Now they're part of this placemat. You can rename it to whatever. And in theory, convert to subgraph. Nope. This one is a subgraph that I kind of made. But I think all these nodes are busted too. And I'm not quite sure why that is. You can also make a variable port here for your entire subgraph. So now this variable here is an entry port into this subgraph. So we can maybe save it. Go back into our main. And now we have an input port here that we can say go into here. And then we can have an output port as well. Then we can do this. So in theory, after this quest, we'll roll into this, go through this dialogue, and then back out. You can also break this out into its own asset. We can try this. I'm not sure if this will actually work or not. So it did, but all the line knows it did. That's annoying. Can add more. So yeah, hopefully they can get the bugs worked out there on that. I think that's just a problem with the duplicating nodes. Anyways, all right, so that kind of wraps that up, really. I'm going to keep working on this kind of quest system here to get it working in runtime. I had it kind of working where it would load up these quests into a big list, kind of like how the dialogue system did it, and was going to try to get them to actually spawn in world, but I kind of ran out of time. So yeah, we'll wrap it up here, and then probably in the next few weeks we'll come back to this and see how far I can get. So yeah, if you guys have any questions or whatever on this, just drop a comment, and we will see you guys next time.